Hello, everyone.
Hello, welcome everybody. Um, Good morning, good afternoon, good evening. We are covering here several time zones, I guess. Yeah, Terrell, who are you?
Yes, so welcome everybody. So I'm Terrell Russell. I'm the executive director for the iRODS consortium, uh, and I'm glad we're all here today.
Yeah. Yeah, my name is Marco Merkel from Do IT Now. I have the pleasure to co-host today this workshop together with Terrell from iRODS, the consortium, and our guest is Nirav Merchant from the University of Arizona, CyVerse. Welcome, Nirav.
Thank you,
Uh,
Marco, and thank you, Carol and the team.
Super. Yeah, it's a pleasure to have you here. And yeah, you did a couple of preparations for us. It will be definitely a fantastic workshop today. Our topic today is actually ensuring data security. So iRODS strategies for enabling agentic access into FIPS or HAPA compliant environments. So in simple terms, we are going to look at how AI agents can safely work with sensitive data and in environments where FIPS and HPAA are non-negotiable without giving security and compliance. Yeah, if you could please go to the next slide. That's our introductional slide. So actually, we already accomplished this. Um, but also, we are now together here roughly about 60 minutes. We will end with a Q&A and a short wrap-up so that you go out here with a clear takeaway. Plus, we put questions into the so please put your questions into the chat as we go. We collect them and bring you up to them into the Q&A session. And you will see live also recorded demos. So if something behaves strangely, that's just a classic live demo tax. So please, yeah, be with us and cross the fingers, and we will explain what should happen and why it matters. And important, we are not using here real patient data today. It's everything you see is demo tested test data, which has been prepared by Nirav. And we talk about HIPA and FERPS. To get a better feeling who is now here in the room, maybe you could be so kind and drop us a letter into the chat. So if you drop an A, you're actually that's a little poll that we're getting a feeling who is now here in the call, who is mainly security compliance interested. B would be mainly HPC infrastructure and DevOps interest. And C would is actually mainly research and data science. And X, I'm just here to see what breaks. So I hope not to see too many X's. Please fill in the the poll to get us a better feeling. Right. So is something happening? Yes. Yeah. Okay. Okay, the A and Bs are coming in. That's good. C. Fantastic. Right. Good
I'll
one.
be disappointed if there's no X.
No X. Okay, someone just for fun putting an X in there. Thank you. Next is coming. Good one. Right. So it's actually a nice mix. It gives us a good feeling. And yeah, anyhow, this session will be recorded. So you can share it later on with colleagues which couldn't make it today. And we are jumping into this. Yeah, if you could be so kind and go to the next slide, we want to actually brief you and give you an overview about the challenges and the solutions. I'm breaking this off, so we are diving into the HPC and AI data problems and what are the three pillars, so automation, compliance, and AI integration. Terrell will jump into how to enabling the technology with iRODS and the policy engines and automate these workflows. Really, really cool information. And Nirav will give us then a live show how AI integration in action looks like. So including here sandboxes, AI, Word, MCP server demos, and so on. And then we're kicking off the Q&A and wrap up. Then in the after the Q&A session. Right. Okay. Next slide, please. So the challenges and the solutions. So that's actually in most in most HPC in data intensive environments, we see the same pattern. So data are exploding, instruments, simulations, pipelines, and multi-project environments actually are exploding the data. So the teams want to plug LLMs or agents into it that the data getting right now, right? But then at the same time, FIPS or HAAPA impose strict requirements on who touched which data, when, under which policies, and under which conditions. And even if you're doing international research, you have then even GPDR or other compliance topics to be answered. So in many organizations, it's still a bold AI to on the side and a model here, a prototype there, and only later someone asks, can we actually show the complete audit trail for what this AI agent did? Then you have a good question on there, but it's how to manage this strategy and how actually enable this is a large and a big problem. So this approach is actually focusing on today. It's built in three pillars. So automation, compliance, and AI integrations. So with number one, with automation, you're having a programmable data store, right? A policy engine that can turn organizational policies into machine actionable code, right? And that covers things like data movement, placement, replication and retention, and check some validations. So metadata extraction and conformance. So that's a huge step into it, but iRODS gives you all these capabilities to embed these functionalities, to having a platform which actually helps you to lead into compliance. On top of that, iRODS brings you the building blocks for FIPS or HIPA relevant controls, right? So protocols, accessibility and permissions for S3, HTTP or ACLs or authentications or authorizations can be easily integrated and gives you also audit and matrices with plugins and logs, which tell you exactly what happened and when the data being touched by whom. And that's a very important, relevant part because you have to manage this data compliant. So the data layer doesn't just store bits, it enforces how to use those bits and how they are handled. The next one is actually the AI integration. So once this foundation is in place, you can plug the agentic workloads with MCP servers. So with large language models and tools in a way that doesn't bypass policies, but works through it. And that's exactly what we will see from CyVerse later on in an AI sandbox that's actually temporary and protected and controlled with a proper audit log and Kubernetes with Kubernetes metrics. So just for a clever demo, we are showing this then later on how to solve then these issues. Close your so today we are diving now into this policy awareness data fabric based on iRODS, and then we are diving into the agentic access with the MCPs on top of it, and we are showing you also production examples at CyVerse that shows this work outside of the slides. To explain now this technology, how iRODS actually does this, I hand over to Terrell because he's an expert in this. And Terrell, the floor is now yours from that
Excellent.
view. I hope I could address this a little bit, and please forgive me if I forgot some things. I'm not a super specialist in data management, but actually that's what I heard from my former times in the file system sector, and that's how we actually cooperated many times with BGFS and iRODS. And we've seen there also many requests from customers how to manage data based on policies and manage the data compliant.
I think we are well set up for success. Thank you. So yes, big picture, zoom out. I think most on the call may already know some of this, but for those who don't, and for those watching this into the future, so iRODS itself is an open source, policy-based piece of software. It is effectively a programmable virtual file system, and it is in production use in a number of places around the world. It provides abstraction for storage, provides a metadata catalog, not just for system metadata like timestamps and sizes, but also for user and administrative defined metadata about what the data is, where it came from, how it got to be that way, and maybe even where you want it to go. So annotations on stuff so that things make sense, as well as a policy engine. It's a rules-based system where uh, code can be inserted into the system for every operation that happens, and then that code can fire. So you can imagine what all kinds of different things that you can do with that, as well as the capability to federate between these different namespaces with different organizations or within different units within the same organization. And all of this code and everything is managed and run by, well, the code itself is built and the process is managed by the iRODS consortium inside of RENC, which is the Renaissance Computing Institute at UNC Chapel Hill. But we do not run this code for you. We do training and support, get people off the ground, but largely we've found that people want to run this themselves once they understand what it can do. Next slide, please. So Marco talked a little bit about this. The rule engine is kind of the heart of what makes this part that we're going to talk about today relevant and good. Uh, Policy set by an organization has traditionally been enforced by humans with processes. Of course, humans get tired and have fat fingers sometimes and forget things. They also retire. Uh, they leave. They lose their organizational knowledge when these people leave. So the idea behind this is that you can encode this organizational policy, whatever that means, into code that can be versioned and audited and refactored, and it doesn't go away when someone retires. And the types of things that you can do with policy include all the stuff that you can do inside of a file system, as well as verify things have gone the way that you want them to. Marco mentioned a few of these: movement, verification, retention, checksums, but as well as all the stuff around metadata in terms of making sure that they're good, making sure that the data is good before you build a pipeline. Um, and so all of this stuff can be automated in a way that is auditable and referenceable and versionable. And it doesn't have to be just inside the system. It can also reach out, of course. Your computer's on the internet, they can reach out to other services, collect data, make decisions about things based on responses from external APIs, all kinds of stuff. Next slide, please. And so with all of that, the point here is that this is a very strong foundation for your robots to start running around, but not in a crazy way, but in a way that is controlled and they can do what you want them to do. So all of the systems inside of iRODS go through the authentication. So, permission models are enforced, the abstractions are held, the policies are in place regardless of which robot came in, as well as, of course, firing, like Marco said, all of the policies that are lined up for that particular scenario. And so AI systems can come in and either provide context or gather context. They can, uh, you know, anything, right? This is a programmatic environment. So once you've got code running inside of a system in a and a system that is boxed in and sandboxed and safe, uh, it really does provide a landscape for uh, the policy and the kind of stochastic nature of the agents to work together in a way that's new and different, and I think very powerful. And so the last point down here is that with with this programmable data store, you can actually protect the various parties and the various pieces of the system from each other because of the fact that they can't just access everything, and you can control which parts are good and where the data is flowing. And I think that that is enough. For now, the idea is that this can provide the basis for strong enforcement of particular compliance requirements, including HIPAA and FIPS, among other things. But particular installations have to make those claims. The iRODS software itself does not claim to be HIPAA compliant or FIPS compliant because that's usually a feature of a particular installation. So I will leave it to Nirav next, I think. Next slide.
Yeah.
There
Thank you,
you go.
Tara. So yeah, we've seen this foundation. So iRODS as a storage abstraction, metadata catalogs, and policy engines and federations. So with this rule engine, you can harden organizational policies into machine actionable logics. And that's a really, really beautiful part now. I would highlight to it because we just had recently in Munich an HPC roundtable where Terrell was actually also a part of it on stage where we discussed how to manage data wisely into infrastructures with HPC and AI, and having MCP servers on this. And I'm really glad now to see now this movement because Nirav Merchant who has done here a fantastic job, and he has already MCP servers ready for us. So I'm very happy that have you here from the University of Arizona. You're managing here over 125,000 registered users on 7 petabyte. Please give us some insights. I'm really, really curious about that, what you actually already enabled here is in cooperation with iRODS.
Yeah. Thank you, Marco, and
Welcome.
thank you, Terrell. Can you guys hear me okay?
Yes, sir.
All right. So I also saw part of my team is attending today, so I really want to acknowledge their presence, and everything that I'm going to talk about is their body of work. I saw Tony, I saw who's our data engineer, I saw Edwin, and I think if somebody else, yeah, Ilyong was there. So Ilyong is creator of many of these products that I'm going to talk about. So let me dive right in. So just a quick background, CyVerse is an open science workspace. It's been there for a while. Our emphasis is on security, privacy, and sovereignty. And by sovereignty, we mean the data being under your control where you need for it to be. And the federation is important for us because we want a unified namespace, but then you keep what you need where you need. We were funded by the National Science Foundation till last month for 17 years, which is not usually typical. But given the success of our project, they continued funding us for a long time. We have a lot of registered users, a lot of data, and the communities are really diverse from astronomy to zoology, A to Z, and I mean it. Uh, there are communities that are able to do their work because of the flexibility we have within the infrastructure. And this infrastructure in itself supports national AI institutes, synthesis centers. And so anything that is a group or a team science activity, it fits really well within our ecosystem. Our core partners are the Texas Advanced Computing Center. So since we are talking of iRODS, the replica of all our data goes over to Texas. And a lot of our HPC tasks run at Texas Advanced Computing Center. And then Cold Spring Harbor Labs is where a lot of our outreach and training happens. And then we are a very active contributor to the iRODS ecosystem. Some of you may be familiar. The Python binding came from Edwin's students. The Go client and Go commands is from Ilyong. Even the Kubernetes CSI drivers are Ilyong's work. And then the MCP for a lot of our LLM agents is Ilyong and Edwin and everybody working together because we realize this is a common need. So iROD plays a very critical role for integrating our on-prem and cloud because we also have presence in Amazon S3 buckets, and we've been very vocal about harassing Terrell and his team about being S3 friendly, and I'm so glad to see those things coming together. We have multiple flavors of CyVerse. CyVerse Health, which I'll talk a little bit about, is the HIPAA, and those of you not from the US, that is the compliance we have to follow when we have anything with patient. And surprisingly, the I in HIPAA is insurance. So you can imagine it's the money that drives all of this. So the HIPAA is a big part. And then the defense, so there's cyber's defense, and we have few applications in that space as well. So talking just specifically about HIPAA, what it turned out is we could not just keep our existing public cybers and then make parts of it available in a compliant manner. As Terrell pointed out, that when you are doing it on your own campus, the laws and the rules and rituals are dictated by the lawyers in your entity and what is their appetite for risk. They interpret those fairly broad instructions to their understanding to keep you compliant. And so having an infrastructure that can meet the sort of minor variations is really important. And we were able to get that through iRODS, but we were also able to create this enclave. So, enclave in the sense that it is a perimeter that we have, and everything that we do is inside of it. So, there's an iRODS inside of it, there's an HPC inside of it, there's Posit Connect inside of it. So, we have many, many applications, but then CyVerse Health is the main one that manages all the data, the containers, and I'll show you some of that. It does handle external data transfer and sharing. We make use of Globus because a lot of the groups are used to that, so that all integrates well. And our environment runs on Amazon Gov because that's what our uh, compliance folks wanted. And then everything is on S3, and then iROD sits on top of our S3 and Amazon. The rules, policies, metadata, audit log that meets the compliance comes from iROD. So we are grateful that we don't have to run around trying to figure out what is where. A lot of our logs for our campus go into Splunk, and then they're managed by our security team there. We also provide SFTP and Go commands for transfer between our systems so people can move the data. And then we use the Kubernetes CSI drivers for mounting the data in our containers. And I'll show you some of the container orchestration. So that sort of is our analysis enclave for this. So I'm assuming most of you have heard of MCP and are aware of it, but for the ones that are not, this is a copy and paste from the Model Context Protocol website. And you can think of it like the USB-C port for AI applications, where it provides a standardized way to, connect things. And it's something that most manufacturers follow. Uh, People like Apple take a while, but eventually they come around. Uh, and so MCP is the same for applications and allowing AI agents and others to talk to data and applications. So with the proliferation of Gen AI tooling in the last, I would say, 2 years more so than three, is that people wanted to build conversational interfaces to large data sets. They wanted to have a conversation with their data and find things. Some of them wanted to create better ways to locate and find data. So you must be aware of RAG, retrieval augmented generation, where they want to be able to ground some of the results only coming from that context. And then a lot of the science data is, people are using embeddings and different kinds of embeddings to find things. And then there were many groups that wanted to automate and curate the data and apply metadata And curation was always bottlenecked because of the human effort that was going in. And some of these were now getting really good using the Gen AI tooling. And so bringing some of the compliance, or whether it's trying to make it fair compliant, and applying metadata that's machine derived, was becoming a reality. So there was a lot of interest in that. And then tools to summarize data and launch analysis. So if something met something, can you run this analysis and give me the results? And so the ability to do that, where agents were analyzing data, was on top of the mind. And now it's in the last few months, it's taken on a very feverish pitch because the word agent is being thrown around everywhere. So MCP was definitely something we had to have a good grasp on. But I would like to point out that MCP is the tip of the iceberg. There's a lot more that you need that's below. I would say that 90% is below the what you see on the surface of the water. And so, it's like history repeating itself, where people are like, I want to download 2 petabytes of data onto our HPC from somewhere else so that I can, run it through my model. Or I'm going to create embeddings, and where do I put them? Or do you have a vector data store in where the data store is? Or can you stream this data via HTTP, because that's what the system handles? And because it is very slow, can I launch 200 agents to download all the data very quickly to do what I want to? And so people were also looking for a place to test the agents at scale without causing damage, because we all know what happens when you give full file permissions to agents. Um, Bad things do happen from time to time for too many people. And so, how do I also prevent my students from bankrupting me? Because if I create an OpenAI account with budgets that are very flexible, trying to embed something or run a large file through it to get some output, you burn through tokens like there's no tomorrow. And so there was that concern. And finally, the denial of service becomes very easy with AI tooling, because you can orchestrate things in ways that you could not do before. And it's a good thing, but it also is a bad thing. And so we started seeing all of these things repeat itself, that we've seen over time. And so we had to go back and say, how do we address the bottom of the iceberg, to make sure that we are not going to sink or have more Titanics around us? And so we already had the federated data and the fine-grained access control and policies, thanks to iRODS. We had our identity management for our users. It comes through Keycloak, and the mechanism to control concurrent access for users, and limiting which IPs are consuming how much bandwidth. A lot of the work Tony has done to keep our systems more resilient and not get denial of service, but we were still running into issues where some of these bots that were looking for data sets would come and attack us. And literally at one point, and Tony can correct me, we had quarter of the internet addressable IP space banned by us, because these bots were popping up in different parts of the world and continuing to do the same attack on us. Well, they didn't see it as an attack, but these were open data sets, and they just felt they wanted to get everything that we had. And open science was under attack because these guys had no idea what they were doing with it, but they wanted the data, and they were coming on slow connections. So that sort of was a challenge. And then uh, we also had started working on managing our LLM inference service. So AI Verde was already in its infancy, and we had it ready to allow us to use inference services from multiple vendors. But we also needed, so those were commercial, but then we had on-prem GPUs with LLMs, people with their own models, open weight models. And so we wanted to unify all of that, and AI Verde was what we did, and I'll talk a bit about it. And then we have a managed container orchestration service, which Marco briefly mentioned, where it runs under Kubernetes. It's called the discovery environment, and I'll talk more about it. And then we had an extensible API to everything in our infrastructure. We've always designed APIs and then built on top of it. And so Terrain, API 6, which is an Apache project, all of those were there. So we had the ingredients, we just had to put them together in a cohesive manner. So we set out to do that. And so bringing sort of MCP to iRODS, we implemented an early version for public data sets within iRODS, and I'll show you that. And then as single sign-on and authentication became more integral to it, just a few months ago, Ilyong and others have implemented that, and that is now part of our MCP. It allows the user to see their own data, but also data that's shared with them. So that makes it very convenient. And then they can deposit the analysis in a different area, but read the data from another area. And so this extended the capability of into our container orchestration environment where we can now create these sandboxes with very specific applications already in it. And then John, who I don't think is on this call, you know, he also has Project Foundation, which does the launching of the jobs and positioning the data if in some cases if it has to be made a copy or if it needs to just talk over CSI. And I'll show you some of those examples as well. And so this allowed the agents to launch the jobs in the sandbox. And then the team validated popular tools for agents like Claude and even accessing it from VS Code. If you need to know more about our iRODS MCP, Ilyong did a presentation at the last UGM, and the PDFs are online, and so is the YouTube video. So just go to the iRODS website. And then our iRODS MCP implementation is on GitHub, but it's not completely open sourced yet. Some of you may know the challenges academia is facing in the US, and we have to go through now more complicated processes to do certain things. So now I'll jump into just like a quick overview and then into videos of the demos that we put together. So here is a typical journey that our users see. There is an HPC sort of cluster somewhere. Somebody's flying drones and UAS. They're sending some data through satellite broadband, some through 5G. Some of that goes into Amazon. Some comes into sort of the NSF, which is National Science Foundation in the US, which is funds a lot of our research, or US Department of Agriculture. And it goes into different places. And then we have to make that cohesive for a community of users. And so all of this happens here where we make the data journey more manageable. So here is the researcher that often is the data producer. And so they will bring in the data, and that data goes into what we call the data store. It is based on iRODS, and it plays a very big role, and we stand on the shoulders of these giants. And then we have a computing environment, the discovery environment, which is a Kubernetes cluster, where people have access to working with the data and the analysis tools, designing their own containers, pulling in their own containers. And then there is something called data watch, which are events. So if something happens, new data arrives, you can trigger things. This all comes from Edwin's team. It's called Cacao, which is cloud automation and continuous analysis. This can either send data, your analysis to commercial cloud or to NSF cloud, like Jetstream 2 is an OpenStack cloud, which includes GPUs and others that are available at no cost. So if you're a US-based researcher, you should be using these systems as much as you can. It's competitive, but you have access to it. So the researcher is either using the discovery environment or Cacao and then utilizing all of these capabilities. And it doesn't matter where their data is or where the computation is. We make it fairly seamless for them through these tools. And that's a conversation for another day. And so here is iRODS, and you guys have always seen some of these slides where there is multi-protocol access. There's desktop clients and command line and Kubernetes and HTTP, SFTP. So there's data accessibility that we like, the data sharing and access control that we love, the data discovery part, And the most important part for us is data virtualization because, as I showed you, our data sits in so many places. The user's journey is very different. It's not one monolithic storage system that we own or the user owns. We beg, borrow, and steal from many places. And the policy automation is really important for us. And so then we sort of stuck in the OpenAI and Claude and others as a way, and the MCP allows these to now become, even though I haven't shown the protocol here, it's based on HTTP, and we have that tooling in place. And so we'll take a quick look. So I wanted guys to also have a view into the deeper discovery environment before I give you demos. And so this can look very complicated, but on the right-hand side is sort of where you see the key cloak, and CI logon is a way where we can just use, if I share something with you with your institutional ID, no problem. It'll make you authenticate with your institution and bring you back. Or you can just get our own, but this allows us to do that very seamlessly. And this will play an important role in connecting the MCP client and authenticating. And so the users come here, they don't see any of this that's below it. Here you can see S3, University of Arizona based storage, tag based storage, and iRODS gives us that abstraction. And then there are CSI drivers, which then, as the containers are launched in our Kubernetes environment, they're able to then see the data and do things with it. And we keep our containers in our own repository, but it can also go to Docker or any sort of container repository that you can pull from. And so all of these things together, along with private clusters, allows the users to manage their teams, their data, and applications that's integrated with single sign-on. What does that mean? So if you launch a Jupyter notebook in our environment, the authentication is already managed for you. Your Jupyter notebook is not open to the world. You're not leaking the data. And if you are inside our enclave, it's exactly the same. The only difference is you now have a perimeter that gets even more strict. So the person has to first VPN and then do these things. So it's really at two levels of verification before you touch something in the platform. And so you can launch any application that has a web interface or command line, and you can manage the full application lifecycle and even who can see or cannot see it. And then your containers are automatically cleaned out. How long they run, you can control how long they run. You need more time, you can ask for time. You can have quotas of how much time you have. So it's all very convenient. And then you can create like shared clean space for people and teams to work. Often they're called clean rooms. And then we have APIs for automation, so you can make it do different things as you need. And now I'll switch gears to you and talk about how we deal with the LLMs. So AI Verde, which stands for Virtual Explorer for Research, Discovery, and Education. So this is sort of our gateway for AI for everyone, where it handles the authentication authorization. You saw our key cloak. If I say I want to give this to Marco, and Marco's at this university, and I want Marco to spend $2 on my OpenAI account, I can very easily do that. I don't have to go to OpenAI. It's just one token that I got from OpenAI, but I can share it with my team and I can control that. So the instructor can, or the researcher team can manage that. And the budget management is very tightly organized. And then you have RAG pipelines, you have chat UI. So all the custom LLMs that are coming out for analysis, you can provide these interfaces to them. Underneath the covers, it's a VLLM and light LLM that we handle things with. And then the Claudes and Friends and commercial LLMs that we want come right through it. So the end user has no idea that they are, the model is coming from elsewhere. They're just using the same OpenAI compatible API, but the keys and the budgets are all handled through AI Verde. And then you can have all sorts of other, like Open Web UI is available. And so it becomes very helpful when you're teaching workshops or you have your project and you need 5 keys for pushing something out. You can very readily do that. You're not having to fight with each vendor separately. It's all done in one interface. So this has been a game changer for many of our projects. So now I'm going to switch into demos. Now, thankfully, these demos are recorded, and I'm grateful to my team because they know my ability to screw things up. I'm going to keep them at a quick speed, but I'm going to pause and make comments. And since my team is also here, um, feel free to stop and highlight something that I may have missed. So I will now give you a quick background of what we are going to demo. So first, we'll show you how to configure and connect the MCP into our data store. Then we'll use Claude Desktop, and the user will access their own data and also data shared with them. And they'll also try to go into data that they don't have access to and see how the agents behave with it. And then it'll also generate some summaries and plots, and it'll even write its own code to do some of that. And then we'll look at VS Code and how it does something very similar. Then we'll go into Claude Code, which is sort of a different Claude product, but very similar. And then it'll use the API to launch applications, and then it'll launch Jupyter notebooks, but this time it'll launch it with GPUs attached to it. And then finally, AI Verde, where you can see how you can put quotas and set this up. But all of this together is what you need to have the real iceberg and not just the tip of the iceberg. So I'm going to jump into the demos now.
And it's 11:43, or for you, Narav, 9:43, just to let you know.
How many more minutes do I have? I just want to make sure I'm not like.
If we want to have Q&A, then you have fewer minutes.
Okay, yeah, no, I think we should have Q&A. So let me jump into the first one. And come on. I'm going to keep it at double the speed. So here, you're seeing how to connect the MCP, and it's connecting to the data store. It's finding data sets that are agriculture phenomics data sets. Uh, It'll then look at it. It's talking to the data store. It found things. And this is now through the public part of it. And you can see what it has found. It's going to summarize those. And then, you're seeing all the allow parts where the person is allowing it to see that data. But then it keeps going further as it's finding. So the ability to find more data sets, and you can see the summary is really actually pretty spot on. And then it gives you a final report of what you have. And so many of our users over time have, and I'm just going to pause this, struggle to get a good summary of what is their data holding. And this really goes through it, calculates the amount of data, what it is, and identifies things really nicely, including the metadata. And now you can see it tells you how to even go get more of this. And now it's going to ask you for, you're asking for a deeper listing. So it's just going to go into the directory and get a deeper listing. And notice that you're not referencing it by path, but you're just saying, here is the TeraRef data set. So that conversation with your data is very different than you having to know exact syntax of where to go. So you can see it's done a decent job of that, and then it tells you how to go get it. Now I will switch to another one. And let me go here. We'll give you a more deeper dive into how it's set up. So you can see they're setting up the custom connector. You can just give it a name, the MCP name, and then the URL is just mcp cyverse.ai/mcp. And you'll use OAuth. For a second, you will see the screen go blank because it's going to a web browser, and that is not shared right now in this demo, but you'll get to see it. And then once it's successfully authenticated, it'll bring you back into Claude, and then you can see there it is, and you can now start doing things. So here, again, they're going to ask different questions to it, and this time it's going to be within a data set that the user doesn't have permission. So now I think Nick is going to try and go into my folder. I think so, yes. And he doesn't have access to my data. So you can see Claude trying to figure out how they're going to get it, but the listing is not happening. It is going to fall back and eventually tell the user you can't do this, which sort of is more reassuring than just getting an error. And I'm happy it didn't say, let me show you how to hack it or something. So, but the good part is you can see that the permission models in iRODS are, honored. It tells the user, hey, you can't see this, but you can see this because you have permission to this and to the public data. And so it's really, helpful. And it also tries to tell them how to get access if they need to. So again, it's pretty powerful with that. And now I will switch to a VS Code version. So here, Ilyang has put this together where the same thing is now done inside of VS Code, where you go in and set up, go to the command palette, put the same information of adding the MCP server, and you're going to see Copilot do the same thing that Claude did, but a little bit differently. And I'm hoping for most people you're able to see this in your uh, in your screen. The fonts are a little bit tiny, but here it goes, and it's now going to ask for permission to authenticate. And in this case, you will see the browser pop up, and because I think the whole and you can see Ilyang is going to log in with his credentials on Keycloak. It'll let him in, and now he's going to do some analysis and produce summaries that are visual. And that's pretty neat. It'll fly through. I'm going at a pretty quick speed, but I don't think it matters what's scrolling on the screen. Um, it's going to summarize it the same way as you saw. But as each LLM has a different style of summarizing, you can see it's creating a different markdown with more details. And you can customize most of these. Uh, And so now he's saying, go show the files. It's showing the files. It's going to give an overview of what's in that file, a collection of files. And now it's an important nuance here. When you have large data sets and you want to pull them in using parallel transfer instead of the agent trying to slurp it over HTTP. So Go commands is what's already installed. So Ilyang is now going to say, download this file for me using Go commands, and it's already installed in the sandbox. And so it's going to use that, pull it. It found it. You can see right on the left corner the progress. And now it's saying summarize this document. And so it's going to summarize the document, but now it's doing a lot of local things. You can see the Linux commands fly by, and then you're going to get these summaries uh, based on that. And now he's asking it to get the same file using wget because it already has a anonymous URL, and you can see the agent understands that and does that. Now he's asking it to unzip it, and then it's going to also do some plots. And so there it is. It understands what's in there, and it's going to produce a plot. It's writing a little bit of Python code, and you can see the plots there. And we've had some really interesting ones where it'll read through it and even create the environment from tutorials that were designed for our users. So now I'll switch to the formation one. And here you can see, let me make it double the speed. So you can see this is inside the discovery environment, and he's asking it to list something in the folder, same style. You'll see the listing, and then you're going to get a summary of what those files are, but it's in a different place. And then you can see it's getting more and more details about that file. And then he's going to launch a application. But it summarizes this is botanical research data comparing the leaf and the seed size. So imagine new employees trying to read through this without much documentation, and all of a sudden your data sets are more relevant now. Just because they are sitting in iRODS and MCP is able to do this. And now he's launching an application and he wants the demo folder as an input to it. So it is launching an application. It is taking that folder, it's putting it there, and you can see the analysis is launched. So it's a Cloud Shell, it's a command line, and many of you live in the command line. So it's not just you need web browsers. You can do this with command line. And so I'm just going to say it works, and I'm going to stop this one. But you can see the Cloud Shell come up and the work happening. I will do this one, but the difference being here, you're just going to see it launch Jupyter Lab. So you can say, launch Jupyter for me with a GPU. So it's actually going to find the application, Jupyter Lab, that has GPU, that has that. It's, figuring it out, and then it's going to launch it and let you connect to it, but it's going to do that part for you. So I'll just quickly let it get there. And you can see it found PyTorch and CUDA. And once it's ready, it says open it in my browser. So you can see it'll do that. And there it is. All right, so I'll stop this, and then I'm just going to fly through Verde for you. So in Verde, the key parts that I want you to see is you can request access to it. You can sign in with all sorts of different places. You can see all the courses or projects, if you may. Edwin has access to many projects. You can see who's in your team and how much money they are spending. You can organize the prompts. You can get your API keys. You can see the number of models that we have. It has like a basic interface if you need. You can connect other chat clients to it, because end of the day, it has its availability. So here we are connecting to Open Web UI, which is very popular. You can combine multiple models and run the same thing through different models. And you can see that's happening in fairly quick real time. So yeah, these are ways to do things with AI Verde. And yeah, you can create tutors and custom GPTs all within your control. So I'll stop here and thank you guys, and I'll hand it back to Terrell for questions.
Oh, I'm going to
Wow.
hand it right over to Marco.
I need to recap this a little bit, Nirav. That's mind-blowing. I've been just falling apart because this is really now for those which actually are not living in the VS code all day. What we've been seeing here that here the MCPs are acting as governed gateways into iRODS, right? And the agent is never roaming freely through the storage. It only goes through the interfaces that respect the policies and ACLs. That's really mind-blowing. And from my perspective, I see also other capabilities. Just imagine we could actually managing data based on power consumption, or maybe in valid smart strategies, so based on performance needs or power usage, watts per terabyte or kilowatts or something like that. Especially now with AI worlds, you're having to feed in the HPC data into the large language models, and you need to take care about the GPUs and the power consumptions as well, right? So the cost of could be impacting dramatically. So MCP servers plays, I think, nowadays significant roles. So what you actually had shown now is now a governed gateway now into iRODS and managing data wisely and pulling off the data for the particular project, but you can go even further. So I don't know. I think, Terrell, we had this discussion also in Munich on the HPC roundtable, managing data based on power consumption, right?
Yeah.
Yeah. Yeah, we talked about automatically routing things, saving it for later, detecting patterns and holding off on jobs until the power is cheaper, or the
Exactly.
network is not clogged, or the storage is not, whatever it is, right? These are
Right.
all external factors that can be inputs into, a decision function.
Super.
Yeah. So I think the point you guys made, the key part is we wanted the innovators who were building solutions which all needed a API key to a very specific LLM, that was the bottleneck. So if you build something and give it to someone and say, go get an OpenAI key, or you have to give it to them, you've already minused out so many people. Or
Yeah.
if you are saying that use this, but don't spend more than $1 on it, or whatever that might be, or you have a custom GPT that you want people to use, how do you give them access? And so this between what AI Verde does and what the MCP does, the data and your innovation that you've built that needs the LLM are all together. And that makes it very easy to share that innovation. So if you now build this power consumption calculator that is plugged into your Slurm that pauses and
Hmm.
starts things, well, it needs to call out to something, and that call out can handle all of that independently, but in a very measured way. And so
Yeah.
our goal was to make it easy for the innovations that are happening that need LLMs and inference as a core tenant and speaking with agents. And you also saw, I mentioned sort of the data watch and triggering applications. So this is sort of where if your data arrives in iRODS and it needs to be annotated, and you need the LLM to do that for you, all of that is now automatically done and it's easier to do that. And so, yeah, we are pretty excited about what people are starting to build with this. And we have some projects, especially in the astronomy side, where it's an LLM that designs the workflow, manages the telescope, and then even analyzes the data and brings it back into iRODS. So it's pretty
Hmm.
cool.
Pretty cool. Yeah, we have a question in our chat. So, Michael Conway, you dropped it. Maybe you just can repeat it because we can hear you. The mics are open.
Yeah, this is for you, Nirav.
Oh, so the question is, yeah, recommending tools. Mike, you nailed it. And so this has solved the problem at such a high level, and it's so accurate where we are no longer maintaining a catalog and the semantic web components to match things and an ontology. This is just reading the description and it says, oh, you need Jupyter Lab. Oh, you want one with GPU. Do you need it with PyTorch? Oh, which version of CUDA? So it's not even like you have to be so specific. It's the conversation that's going. Yep, we brought Clippy back.
Hmm. Awesome. Right. Yeah. Mm. May
So
I drop a question?
please.
Yes.
So, since we're having here with a lots of experience, I mean, on a 90-day playbook for the rest of us here in the call, right? So, if a team has already iRODS, but no AI layer yet, and they would ask you for a brutal, honest 90-day playbook to move towards in an agentic sandbox like yours, what would you tell them to do first, and what should they postpone, and what should they absolutely not to do? I think that's a good one for people which actually now having iRODS and say, wow, I want to go that path. But it could be a fantastic, yeah, sharing is caring. Maybe you can share some thoughts in this kind of direction. Mira.
I think the most important piece is as long as you have the policies in place where your users can see what they're supposed to see and the access control is in place, then you're able to dive forward. But if you have all these things where you're hiding it from them using different methods or abstractions that are not integrated into iRODS, then this makes it trouble. So by that, what I mean is if you're keeping your S3 buckets in Amazon and that access is done differently and that's not integrated and it's not visible through the iRODS part, so you do some shifting, then it becomes really brittle to implement. But if you have
Mhm.
all of that unified, or everything you have is open in some cases, then that's a different conversation. Then it's easy to layer up the MCP components onto it and then integrate that with your identity management system, and then let your users choose their poison of paying Claude $20 a month or $200 a month, or using something that you have in-house. I mean, there are many MCP clients. It's not just, and there are free ones that we also use. And so then you connect to it, and then the rest is already out of the box. So early proof of concept, just exploring the data and doing some of the things we showed you, is
Mhm.
very feasible if you have this in place.
Mhm.
Then, when you start getting into the sandbox part, you have to start being more sort of aware of how your sandbox and how your iRODS layer, and that's where some of the Kubernetes and CSI and things come. There's caching, and how are you managing your containers? Where are your container applications? And so that needs a lot more designing and architecting, but it's doable if you already have a Kubernetes cluster. Um, to start thinking of those. But provisioning the AI sandbox is a little bit more effort. But as a proof of concept, you can pull it off, but then getting your users to understand and developing policies to manage your containers is another effort. But yeah, all of this, there is a 90-day you can pull this off.
All right. That's a good thing. So it's not too
So
complex, to be
I think we
honest.
have one more question, and then we're going to talk about Barcelona a little bit. So,
Yeah.
Ira Parson says, for someone who wants to tune their own AI with their data, what direction should they go to learn at the fastest pace?
YouTube.
Mm,
Hey, follow tutorials, and Hugging Face is your friend.
yeah.
Yeah, I guess so. Mhm.
So I think we're going to have a slide here in a second.
Okay, let me.
We are happy to announce we're going to be in Barcelona at the end of June next year for the user group meeting. So we're 6 months out, 7 months out, six. I don't know. It's Christmas time. Who knows what time it is? So please consider coming to hear more success stories and maybe some failures. People like to stand up and say what doesn't work as well. Um, and we will be happy to see everyone. We're going to make Nirav make other people give talks next year because he won't be around anymore to do this. He's retiring soon. So thank you so much, Nirav.
Thank you guys. And Terrell, if you can go one slide behind, I forgot to thank the team.
Oh yeah.
Yeah, so if you need to know, there's learning CyVerse, but Edwin and Tyson, and we have an amazing engineering team, and all the demos, Ilyong, Nick, John, and Edwin were responsible for that. So thank you guys.
Yeah.
And thank
I,
you to Do IT and iRODS for this opportunity. And feel free to drop us a note if you have questions.
yes. I can also say thank you. That was a mind-blowing deep dive into policies and MCP servers. I think there is more room to dive more deeper into what you can do with policy engines and MCPs. I'm looking forward. So, Terrell and Nirav, maybe you're also welcome. We'll be thinking about the next topic, what we could do next in the workshop. Could be a series. So please stay tuned, watch us. And yeah, if you need a helping hand, Do IT Now is the partner who actually can enable things and doing support L1, L2. And yeah, we are working very closely with Terrell and the team. So I'm really happy that I was here, the co-host, and I learned a lot into this exercise. And I have to say thank you. And if you don't see us this year, Merry Christmas, have a good time, and stay safe, right?
Okay, thank you, everybody.
Thank you, everybody. And this is recorded. It'll be on the internet later, so you can share it with all the other people.
Come on.
All
Cheers.
right.
Goodbye.
Bye,
Excellent. Thanks a
everybody.
lot. Bye bye.